Greetings, everybody. Let's start in with another example of integration by parts. So what do we do if somebody walks up to us on the street and says, hey, I've got an integral I need you to evaluate. I really need you to figure out what is x squared e to the 2x dx. So what is that integral going to be? It's a natural question to ask, and so let's see what might be our solution to this problem. Well, one thing that we notice off the bat is that we have a product of two functions, that we've definitely got our x squared as being one function, and we've got e to the 2x being another function, and so those things tell us right off the bat that probably integration by parts is going to be a technique that may help us in solving this problem. So just kind of remembering what our integration by parts formula is, that we've got the integral of u dv is going to be equal to u times v minus the integral of v du. And so with that formula, it leaves us then with the natural question of what do we use as u? And so once we choose what we want as u, dv then just becomes everything else. And so with that, now we kind of come in, we remember our acronym LIATE, L-I-A-T-E, to kind of help us to maybe be a guide as to what we use to solve this problem. Remember that L was going to stand for logs, I for inverse functions, A for algebraic functions, T for trig, and E for exponential functions. And so this was kind of our example, or this is kind of what we're going to use to maybe guide our choice in what u and v was going to be. So here we're dealing with x squared, which is going to be an algebraic function. And then we've got e to the 2x, which is going to be an exponential function. And so that tells us that, oh, my u is going to be I probably want to be the one that comes first, so that it will be the algebraic function in that case. And so what I would then do is to say, all right, let's make u be our x squared. dv then becomes the rest of our integrand, which is e to the 2x dx. Now for our du, remember that was just going to be the derivative of x squared. So we've got du being 2x dx. Then we've got v being the antiderivative of our e to the 2x dx. And so for that one, we have a 1/2 e to the 2x. If we take the derivative of 1/2 e to the 2x, now we're right back to e to the 2x dx. And so these are our choices. So now we just follow the formula that we've been given with these choices to see if things get simpler, more simple at that point. And so what we have is the integral of x squared e to the 2x dx. We've said u was going to be x squared, dv was going to be e to the 2x dx, v was 1/2 e to the 2x, and du was going to be 2x dx. So with our integration by parts formula, we had u dv was equal to u times v minus the integral of v du. So that's our integration by parts formula. So we've got u times v, which is going to be our x squared, 1/2 e to the 2x. So I've got 1/2 x squared e to the 2x minus the integral of v du. And so my integral of v du looks like 1/2 e to the 2x. So I've got 2x times 1/2 e to the 2x dx. So simplifying that just a little bit, what we have then is 1/2 x squared e to the 2x minus, killing off the 2's, we get the integral of x e to the 2x dx. So kind of as our guide for our integration by parts, we're kind of looking at this and say, did the integral that we ended up with, is that easier to do maybe than the integral that we started with? Well, in a way you can say yes, and in a way you could say no. Is it easier to do? Well, I still don't know exactly what the answer is at this point. But in comparison, things have gotten a little better in that the power on the x has gone from 2 up here where I started to just 1 down here in my current integrand. And so with that one, things have gotten a little bit better. And so what I want to do is maybe then let's just kind of keep that up a little bit and say, all right, well, things have gotten a little bit better. Let's keep going at that point. And so maybe we've got another product of two functions, integration by parts again. Again, probably so, because we still have the product of two functions. And so the answer to that one is yes, let's keep going. And so that's exactly what we'll do. And so we'll use kind of the same guide that we had before. So kind of keeping this same thing going with what we just had, well, now we choose kind of the same idea. We've still got an acronym, logarithms, inverse functions, algebraic functions, trig functions, and exponentials. So we're still dealing with an algebraic function and an exponential. So we will take we'll try u being x, and dv then becomes the rest of our integrand, e to the 2x dx. So that du just becomes the derivative of x, so that's just 1 times dx. V becomes the antiderivative of dv, so I get my 1/2 e to the 2x again. And I apply my integration by parts formula. U dv is going to be uv minus the integral of v du. So that's my integration by parts formula. And so what happens in this case, well, now my integrand becomes 1/2 x squared e to the 2x minus, now I apply my integration by parts again, so it looks like u times v, so that's going to be 1/2 x e to the 2x minus the integral of v du. And so that's 1/2 e to the 2x dx. And so it's really at this step that we kind of begin to look and say, oh, have things gotten easier? Well, yes, now I'm down to my integrand being very easy to do. I mean, I can almost just look at that and see what the answer is going to be. And so I can see the light at the end of the tunnel. And so in that case, yes, what we've done was the right decision, and we've gone in the right direction. And so we just have a little bit to finish with that one. So let's say, let's kind of keep this going a little bit so that we've got our 1/2 x squared e to the 2x minus, if I distribute that, 1/2 x e to the 2x. Minus and minus becomes a plus, my integral of 1/2 e to the 2x dx. And so now, as kind of my last step, I just have this integral to evaluate, which then becomes, and so this gets us to just simplifying our last integral. And so for that step, we don't need integration by parts anymore. So we've got our 1/2 x squared